So this is the promised instruction for drawing dot diagrams in case you need another run at trying to understand this. So I'm going to do three different ones for you real quickly. The first one is CCL4, that's an easy one. The next one's SO2, has another little challenge to it. And then we'll do this, the one that I told you to skip over. I'll just go ahead and do this here with you so you can watch the video. It's a CO into H4. All right, CO into H4. Where I say it was CO into H4. All right, CCL4, the first one. If you look at your steps over here on your instructions, the first thing you need to do, number one, is add the valence electrons. So carbon has 4, and chlorine has 7 valence electrons. However, there are 4 chlorine atoms, so you had to multiply that by 4 and you get 28. So 4 plus 28 is 32 valence electrons. Number 2, draw a skeleton structure, putting the least electronegative element in the center. The electronegativity of chlorine is significantly more than carbon, so carbon will go in the center. And a caveat here, there are a couple of other things you can think about instead of just electronegativity. You know that carbon has these 4 valence electrons that we said, so it could have as many as 4 more valence electrons because it would be gaining electrons to get to 8 potentially. Therefore, carbon has 4 open spots for electrons. Chlorine has 7 valence electrons, but only 1 open spot because it only has room for 1 more before you get to 8. So carbon has more bonding sites. So kind of there are 3 things that I gave you in class, was least electronegative and most bonding sites, and then of course whatever is closer to the center of the table. Carbon goes in the center based on all 3 of these criteria. So we put the chlorines around the outside of the carbon, carbon in the middle. Now we realize that we have our skeleton structure finished. We need to subtract 2 electrons for each bond right here. So in this picture there are 4 bonds. So I take my 32 electrons and I subtract 8 of them. That's 2 per bond. So 4 bonds times 2 electrons is 8. So that gives me 24 electrons to put in. If you look at this picture, you'll see that this pair of electrons here counts for both the carbon and the chlorine. They're shared, covalence. So they're sharing their electrons. So the chlorine has 2 electrons right now because of these 2 here in this line, the shared pair. So what we're going to do is put electrons in until we get 8 around it. So 1, 2, 3, 4, 5, 6. Now I have 1, 2, 3, 4, 5, 6, plus these 2 make 8. And I've used 6 of my 24 dots. If I do the same thing over here, that's using 6 more of my 24 dots, and I have 2, 4, 6, 8. I can do the same thing up here. Use 6 more of my 24 dots, and I have 2 here, 2 here, and 2 here, plus the 2 that were already in the picture. That makes 8 around this chlorine. Same thing up here. So around that top chlorine, I'll put 1, 2, 3, 4, 5, 6. And then the 2 that were already there make 8. So now I've put in my 24 dots, 6 around each chlorine, and all of the atoms in my picture have 8 electrons. If you look at the carbon, 2 here, 2 here, 2 here, and 2 here. So the octet rule is satisfied for everything, and that is our final picture. Now if I did SO2, let's take a look at it. I'll rewrite it down here. SO2, S has 6 valence electrons, and oxygen has 6 valence electrons, but there are 2 oxygens there. So 6 for sulfur and 6 for oxygens, but there's 2 of them, so 6 times 2. So the bottom line is you have 18 electrons. So what goes in the middle? Well, they both have the same number of bonding sites. Sulfur is maybe a little closer to the center of the table, and sulfur is the least electronegative. So by rule number 1 and number 3, that puts sulfur in the middle. So you do this. Now I'm going to draw this a little bit at an angle like this for a reason you're going to see in a minute. So the total electrons are 18. We have 4 in our picture right now. Take away 4. So I'm on step 2 where you draw a skeleton structure, and I'm actually on step 3, I guess. Subtract electrons, 2 electrons per bond. So that would give me 14 electrons to put in after I take those 4. Okay, so if I put them in, 1, 2, 3, 4, 5, 6, that makes 8 around this oxygen because of the 2 that were already there. There are 4 around the sulfur, so I put in 4 more. Now of the 14, I've used 2, 4, 6, 8, 10, 11, 12, 13, 14. So I have 2 electrons that I still need, but I don't have them. Okay, so once again, I had 18 to work with. I had 4 in the picture. Take those away. I've got 14 dots to put in. I've put in my 14 dots, and I'm still 2 electrons short right there. All right, now in these rules, I put abbreviated rules in. If you have too few electrons, multiple bonds. Too many electrons, put the extra around the center atom. Which situation am I in? I have too few electrons. How many too few? Well, there's 2. So in class we said if you're 2 short, you add a double bond. But if you're 4 short, add 2 doubles or 1 triple. Okay, so here I'm 2 short, so I add a double bond. So let's redraw the picture. I'm going to put a double bond in. Doesn't make any difference which side you put it on. Now I've got my 18, but instead of subtracting 4, I'm going to subtract 6 because I've got 2, 4, 6 in that picture. That gives me 12 dots to put in. If I put 1, 2, 3, 4 there, that would make my 8 electrons around the oxygen because there's 2 here and 2 there. On the sulfur, I already have 2, 4, 6, so I just need 2 more electrons here. So now I've put in 1, 2, 3, 4, 5, 6 of my 12 dots. I have 6 more that I can put over here. And that's the picture that we'd expect you to draw at this point of sulfur dioxide, SO2. Now remember I told you I drew it bent for a reason. See these electrons up there that I just made that mark on? Those 2 electrons, they repel these electrons. And they also repel these electrons. And these guys repel each other. So that makes it try to form sort of a triangle here. And we call that a bent structure. The fact that it's bent because these guys repel affects its properties significantly. All right, the last picture, CON2H4. Okay, C has 4 valence electrons. So you're going to add the valence electrons first into H4. Oops. Okay. So C has 4. Oxygen has 6. N has 5, but there's 2 N's. And hydrogen has 1, but there are 4 of them. So I've got 10, and 10 is 20. I've got 24 valence electrons. So here's what makes this one kind of hard is it all centers around that carbon. So the one that has the most bonding sites and is least electronegative except for hydrogen and closest to the middle of the periodic table is carbon. So carbon goes in the center of this picture. So I'm going to draw it over here, carbon. All right, from carbon we're going to put in the O and the N's because the hydrogens have to be on the periphery. They can only have 1 bond. So I'm going to go ahead and put the O's in. Oh, there's only 1 O. Put in the 2 N's here, N, N. Okay, now on each of the N's, I'm going to put the H's. All right, now we've got our skeleton structure drawn. We're going to subtract 2 electrons per bond. So 2, 4, 6, 8, 10, 12, 14. So I've got 14 out of there. I had 24 to start with. So 24 minus 14 gives me 10 electrons to work with. I could go 1, and once again 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Turns out that I don't have enough electrons because the hydrogens are satisfied. See, right here they got 2 and they've got 2. And hydrogen can only have 2 electrons. The nitrogen here is satisfied, 2, 4, 6, 8. Carbon, 2, 4, 6, 8. Oxygen, 2, 4, 6, 8. But this nitrogen is not satisfied. We need 2 more electrons and we're out of electrons. So what do you do when you're 2 electrons short? You add multiple bonds and start over. So since I'm almost out of paper here, what I'm going to do is use my eraser function. And we're going to erase these 2 electrons and start again on the oxygen. Okay. So now I've got the same scenario, but this time I'm going to put in a multiple bond. So now the question becomes, which would be the best place to put the multiple bond, the double bond? Probably on the oxygen because oxygen has 2 bonding sites. And I've already got the other nitrogens filled up. There's another concept later that we will talk about called formal charge, which simplifies this process a little bit, but I don't think we're quite ready for it yet. Okay, so I'm going to take away now 2, 4, 6, 8, 10, 12, 14, 16 of the 24. So 24 minus 16, that gives me 8 electrons to distribute. So if I put 1, 2, 3, 4, wouldn't that make 8 around the carbon and the oxygen? So here's 1, 2, 3, 4. Get rid of this little smudge there. Okay, so now I've got around the oxygen 1, 2, 3, 4, 5, 6, 7, 8. Around the carbon 1, 2, 3, 4, 5, 6, 7, 8. I had 8 dots. I just used 4 here, so these 2 that I didn't really take off of the nitrogen earlier. Oops. Okay, these 4 that I have on the oxygen, I didn't take these 2 off the nitrogen, so that's 2 more. So once again, 8. I used 4 here, 2 here. Then if I put 2 more down here, that gives me 8 around the nitrogen. 2 here, 2 here, 2 here, and 2 here. All right, so that's a completed dot diagram. It looks like this. And that's CO into H4. So there's a little review of how to draw them. I think you can follow the rules. It should be pretty straightforward.